Hi there, I'm trying to show you the short video trying to explain to you how I made the parts and why I followed the specific approach that I followed, which hopefully will prove to you that I'm trying to keep consistent with my design intention. Now firstly I will lay out my design intention, and that will be trying to make things even more compact to each other. I'm trying to make so that the space between is not all over the place. That's just my intention with it, and also so that we don't use as much materials as we probably think that we should, and lastly so that it looks slick. That's a part of it all. And so here, this is the lowest one that has a connection from the arm to the servo there. Now what I did here is that, let's suppress this first. Now what I did here, firstly I changed the size of the hole so that and also I changed how the hole was made so that it allows me to just create a concentric mate later on using the tube attachment. The tube attachment is a simple adapter concept that I suddenly got an idea for, and I hope this works, because this one here, it basically, let me just suppress the mate too. Here, this one here, it's basically like something like that. It's just a very basic system whereby it provides a circular face on one end, and it provides a rectangular face on the other, and this would help us to provide a space to place the bearing where it would help to compensate the swinging motion. Now let's put up that mate again. That's concentric, by the way, and then put in the bearing inside there, concentric, and it's locked so that the outer ring remains locked and tight fitted with this adapter, so that whenever the servo turns, it just turns the inner ring. And this here is also locked. This here is also locked along with the adapter. It's a very simple system here, not many complications. Now moving on to the housing, that's what I call it. Let me just suppress all of it first. Now the housing's intention, what I intended to do with this is that I wanted to make it more compact, as I said, with the design intention, and also I wanted to make it easier for users to replace servos, basically, you know. And so firstly, this is the frame of the housing, and then we can put a spring there where there's a place for springs there as well. Now that, so that whenever the servo is inserted, and these are concentric and also coincident to the plane there, to this plane. Now whenever the servos are placed here on top, there's a freedom. Let me suppress that. There's a freedom there, you see, from going in from the top. So going in, there's a freedom, and then it just clips inside. I mean, this is very computer. Let me try to do that actually. I think we can do that. Yeah. So whenever it slides into it, and then it just clicks into, so that they then become a tight fit. That is the design intention. The upper space is free, the lower space guards it down on the left side and also on the front side. Not so much on the right side maybe, but except for a bit there. Again, remember that my design intention is to actually reduce the amount of materials that we use. And then the same goes as for the bottom servo, so that the bottom part here, there's a freedom, there's a free space here, and then there's a constriction on the top part or on its lower part, and you can see that here. Just unsuppress it, so it's a tight fit as well. And that's a servo horn. There you go. And so moving on to the these are all, we'll talk about more about the relationships after this, but here, this is the motor plate. The motor plate, on the other hand, my intention with this, again, the same, which is to make it more compact. I wouldn't want to have too many materials, whereby we could just like reduce what we can do with it. I made this parallel to this one so that we can have a steady motion. It's not all over the place. It will make more sense later on as when I show you the full assembly. But basically with this one, let me just do as I did with the others. Here I started out with the motor plate. Now with these two things that I designed, they're designed to allow bearings to be applied there to the linkages. Now these are just very basic things, like here, let me so these are very basic things. It's just like it's again, it's also kind of an adaptive system, which is just like attach these two onto the holes here and see how it could help in the sense of making the linkages work well with the motor plate, which has a different angle and a different plane totally. Alright, so once we're done with that, we should bolt it up using concentric and also coincident mates. Then once it is bolted, we can now put on the bearings onto 4 of the holes here, suppressing it. So the idea behind this is that it's kind of a reversed system to the tube earlier, the bearing that has to do with the tube just now. Is that this time around, the outer side, the outer ring, is free to move, free to rotate, but not the inner one. Again, I couldn't make this as I want it to be because this is downloaded from Timken, but it will make more sense later on in the full assembly. Here, then you could see that these allow us to connect the links, and the links, as you may have sneaked a peek just now, they are very simple ones. These connect to the servo horns, these parts here, and they both go up and just provide channel to both ends of the plates. Now notice that there is let me show you how. Notice that it is not connected, so it ends there. it is not through the hole, but instead, see that it ends there. And the idea behind this is that we want to allow users, or we want to allow the installation to occur from the outside, screwing inside like this. And the idea behind it is because it's hard, kind of impossible if you were to think about it, if these were to be screwed as a bolt. And so instead I used screws so that they pierce into, instead of the linkages piercing outside. So I think that's a very simple concept as well, that I hope you guys would like it. Yes and yes and yes. Now this is full assembly. Now the idea of the parallel thing, of the parallel connection between this, is that I want to maintain the distance between this and this and this and this, the holes on the servo horn and the holes on the plate attachments that I made, they're the same. And so that's why I could make it parallel, and also that would help in the movement. Now you said that you would like to have a 45-degree angle maximum in the both rolling and also pitch, right? And so that's what I did here. Let's try to do this now. So that's a maximum 45, and also this is already at its maximum, probably, yeah, maximum 45, maximum of 45 as well. Now let's see if this could be cool for a bit. Sometimes it just like spazzes out, but okay, see, voila, see, it spazzes out a little bit, but it SolidWorks as always. I hope it's the same SolidWorks in Sweden. And so yeah, again, I designed this so that instead of having the servo that is connected to the motor plate on the top, I designed it to be on the bottom, so that it takes less space on the upper side. It brings down more space. And also, if you look at this from this angle, right, is that they are spaced nicely, so that whenever they do decide to come around here, they won't interfere. And it's also not interfered whenever it goes down there. You could also see it by yourself for sure in the assembly later as I send you them. Thank you, appreciate it very much.